All right. Hello, everybody. Um, cool. So I'm going to look here. Hi, everyone. I'm Faisal. Welcome to Machine Learning for Everybody. Um, this is the second time I'm giving this talk today. The first time I gave this talk at 3 a.m., and it's noon right now where I am. So I actually think the first time I was too sleepy to properly give this talk, but we'll see. I got good feedback. Um, but this talk is actually very experimental, anyways. Um, this is not a talk with a lot of code, or I'm going to talk about a lot of math. This talk is really about machine learning for everybody. When I mean everybody, realistically, even if you're not an engineer and somehow you randomly stumbled upon DevFest and you click this link and you're watching me, um, you will still learn something here, and you will still learn enough to actually go and start doing machine learning, right? So this is for everybody. Who am I? I'm going to present this actually. You know what I'm going to do? I'm going to do this following. Presenter view. There we go. All right, cool. So who am I? I'm a Google developer expert. I talk about Flutter, Android, decentralized apps when Bitcoin was cool, and machine learning because it's cool right now. Um, that's my Twitter. That's my email. I'm a co-founder at a company called Irene, where we're uh, building a simple modern cremation platform. And I'm a CTO at Bitstrap, where we do a lot of consulting, mobile, web, machine learning. And this talk is really comes from my experiences in consulting and kind of having to deal with quote unquote real world machine learning problems. So, what Google does, what Microsoft and all these guys are doing are real world problems, not discounting them at all. But there's a lot of businesses, I think, Google and all these guys, they're like the top 5% of ML problems they're dealing with, right? The top. But then there's this whole area of ML problems that just normal businesses need, right? They need like simple prediction algorithms. They need like, we have a charity. We want to know which of our donors we should target to get more donations, right? Now, Google is not focused on that. Google's focused on creating Skynet or something, right? But who's going to help these other guys out? So when I do consulting, I'm doing a lot of these pragmatic consulting approaches, and that's where that's where this talk really comes from, right? And like I said, the audience for this talk is everybody. There's absolutely no code in this talk. It's experimental in the sense that I've never really given a talk like this before, other than at 3 a.m. And so in this talk, what we'll do is we'll cover what really is machine learning from a very high level. I'm not going to get into the academic definition. I'm going to get into a pragmatic definition. Now, for any academic person out there who's listening, they might want to kill me after this, but I'm sorry. This is really just about, imagine explaining JavaScript to someone, right? It's a language for the web. You can write code in it and make things happen. That's the type of definition that we'll kind of understand. And we'll get an intuitive understanding of what machine learning is. We'll try to learn what are different types of ways machines can learn. And then the most important part is getting started with the software and resources. And then we'll do questions. So what really is machine learning? Machine learning is not TensorFlow. Contrary to popular belief that a lot of people, especially media, has kind of overblown, right? Machine learning is not TensorFlow. Machine learning is not deep learning. It's actually been around for a long time, right? It's been around for actually a long time, but in a more recent example, if you've ever played Xbox, the Xbox came out when I was a kid, so like 20 years ago, I think, and so when the Xbox came out, they had a game called Forza. And this is the Xbox. This is like the first generation of Xbox, where like Bill Gates got on stage and like went to Best Buy or EB Games and sold the Xbox. Like this is the underpowered machine Xbox. And there was a neural network on the Xbox. And specifically, there's a neural network from the game Forza. And what Forza did was they created a small neural network that just trained the AI to drive like you and compete with you, right? They wanted a very competitive experience that blew everyone away. And so, if you think about neural networks and machine learning, it's not a new invention, right? It didn't just start off when .ai domain names became available, right? Machine learning is not, anyone creating a .ai domain name and suddenly, you're worth $1 million. It goes back. It has its roots in like the 70s and 60s when there was a lot of research going on. And the whole point of machine learning is that you don't want to be typing up rules, right? So actually, before we jump to the rules part, this is the entire genre, the branch of machine learning, right? You have the parent branch, which is artificial intelligence, and then machine learning is a subset of that. And then a subset of that is neural networks and deep learning. Like I said, deep learning does not mean machine learning, right? In fact, in most business applications that you probably will do or are doing, you're not doing deep learning, right? If a real estate company comes to you and says, we want to figure out the best prices, you're not going to end up spinning up a TensorFlow TPU deep learning network, right? It's like overkill. It's like trying to, cut down a tree with a nuclear bomb, right? It probably won't even work. It just will be terrible. So this is what the thing is, the idea the branches are. And so if you click on that link, once you get the slides, that is a great introduction to machine learning, and is also a big inspiration for this talk. So totally check out that website. So machine learning, to get an intuitive understanding of what machine learning is, the idea of machine learning is not to code a lot of things, right? So let's take a look at an example, a very simple example of spam filters, right? Everyone has dealt with spam filters, so you should already have an intuitive understanding of how a spam filter works. When someone sends you spam, it goes in the spam folder. Now, let's say this was you as a first-time beginner, you don't know what machine learning is, and you're creating a spam filter. You would do what most people would do. You would say, all right, I'm going to create an array, a list, for example, and I'm going to say spam words. And whenever an email comes in, I'm going to scan all those words, and I'm going to say, does this email or subject contain these words, right? It could be, I don't know, what are some spam words? I don't know, like Viagra, right? If it contains this word, then automatically send it to spam. Now, the spammers get clever. The spammers like, okay, this person is blocking my word, so why don't we replace the word I with one, right? And now suddenly you're getting spam again, and you're like, oh man, okay, now I got to go type in replace I with one. And soon, you're working 24 hours where you're just keeping these spam list words up to date, right? And that's a very rudimentary spam filter. Now, how do you get around that? How do you tell the machine, please learn on your own, right? It's not like a human. You can't be like, hey, can't you understand? That's not what you want to read. And so you use a bunch of stats formulas, right? Like at a core essence, machine learning is just stats. So you use a bunch of statistical formulas, and you say, okay, if it looks like this and has in the past, whenever emails like A, B, and C have come in, then these have a high probability of spam. So if you see something like this in the future, if it crosses a threshold, then it's also spam. And that's how rudimentary spam filters work. And for the most part, they work really well, right? You don't need complicated deep neural network algorithms. Most of the time they work extremely well. And for the longest time, Hotmail and all these guys were just based around that. And I actually still think most of these email services are based around just using like Bayesian algorithms, with the exception of Google and stuff that have gone really advanced. They're looking at NLP now and context and a bunch of other stuff. But, the traditional approach has always been, I have a bunch of rules, I have a bunch of data, tell me the answer, right? So I go, okay, I have a bunch of rules which are, if the word contains Mickey Mouse or chair or dog, then it's spam, right? Equals spam. So next time that data comes in, it matches the rules and it gives an answer. The machine learning approach, though, is data plus answers equals rules, right? So I'm giving the machine data. I'm also giving it the answers. And I'm saying, with these things, come up with the rules for this. And that's a big insight, right? If you're struggling to understand machine learning, try to understand, like write this down. It's like an equation, right? You're just kind of swapping stuff around, but data plus answer is equal to rules. So I talked about spam recognition. Same thing with handwriting recognition, right? Imagine you want to detect someone's handwriting, right? So what you would normally would do is, if in a traditional approach, you would basically get someone to write the word C and A and T, and you would say, okay, this person C looks like that. You would do some OCR recognition and match the black and white and say, okay, whenever there's black pixels that look like a C, that equals a C. Now, what if someone comes around and writes C in a totally different way, right? Suddenly, your algorithm is broken. Instead, you can say, okay, let's get a sample of how all the C's in the world look like, right? So you get like 500 people to write the word C, 500 people to write the word A, and then another 500 to write the word T. Put it all together and tell the machine that, hey, here's the data, right? Here's how all the C's look like. And all these images that have pixels that look like C, this means C. So the next time, and then you do the same thing with A and you do the same thing with T. So the next time the computer looks at this, the computer goes, I've detected a pattern in all the different things you've given me. All these images you said look like C. And this new image that I've never seen also fits that pattern. So I'm also going to say it's a C. I'm going to give it a confidence level of like 80%, right? Now, that person could be writing like, I don't know, what looks like C. I don't think anything looks like C, but like person could be writing something else and it actually misclassified it as C. So you train it again. Now, the thing that it took me a while to understand, people gave me this example. I'm like, okay, but what is that algorithm? I came from a traditional programming approach, as did absolutely everyone if you're doing programming. And, you want to know, well, what is that function? Like, how am I actually telling it to learn? Now, there's two answers to this, right? The answer number one is, typically it's this thing called a convolution neural network, right? Or convolution algorithm, and you're like looking at the pixel values and you're doing pattern matching. But that's not really important. If you feel that's important to you, if you feel you must understand how the mathematics works, then there's a lot of good courses on it, right? But you as an engineer that just wants to kind of apply the learnings, right? Like right now, when you write some software, you write some JavaScript on the web, you don't care how the V8 is taking your JavaScript, converting it into an abstract syntax tree, right? And then converting that into like virtual machine bytecode, which then optimizes it, converts it into like basically electrons on the CPU so it can like trigger something on the screen. You don't care about all that implementation. You just care that when you go array.push, something is pushed onto the stack, right? And so like that, modern machine learning in the past, say, 2 years has become very intuitive, where there's a lot of libraries. You just have to know what libraries to use. So in this case, you go, okay, I think I know what type of algorithm this is. This is a classification algorithm. So let me go onto my library that I'm using and see what classification algorithms they have. And then apply one of those classification algorithms and see what their results are, right? And a lot of machine learning is that. It's not true. It's an art. Sometimes you hear this phrase that machine learning is an art, and a lot of times it is. Even like the top world famous machine learning engineers, PhDs, are not sitting looking at an algorithm and know exactly what values to put in. It's impossible, right? They're guessing first, and then they're using educated guesses and intuitive guesses to bring those parameter values so that they get a good result. Essentially, that's what you're going to be doing too. The only difference between you and them is they are probably implementing the algorithms for something very custom, right? Like, detecting like a baby speak for Google Home, right? Google recently launched this feature last year where they can now understand kids who speak broken English to understand what Google's saying. Now, you just can't go to a library and pick a framework for that. So you're writing algorithms. But for most business use cases, you're not doing something so cutting edge. You're doing pragmatic machine learning. And that's what utilizing libraries is all about. So let's look at some ways we can help a machine learn, right? Oh, what happened to my screen? Okay. Now, we're not going to go over all this, and you can get the slides later. So let's take a look at supervised learning, right? There's too many algorithms. You might go, wow, I'm so flustered, Faisal, I'm just going to turn off this presentation. But it's almost like, imagine it in the context of, let's say, like Vue.js or React, right? These are all different features, right? So if you think machine learning is like React, all these are different features. You're not using every single feature in React every time you use it. You're probably using a small subset. And that's what you would be doing here. Typically, when you think of a problem in machine learning, I look at this chart and I go, okay, what am I trying to do here? Am I doing supervised learning, unsupervised learning, semi-supervised learning, or reinforcement learning, right? And then once I figure out exactly what I'm doing, for example, say I want to predict pricing for a house, right? So I look at supervised learning and I'm like, okay, what was supervised learning again? Supervised learning means that I am giving it data and I'm giving it answers and I'm telling it to predict what's coming up in the future, right? So I'm like, okay, that makes sense. That's typically, I have the answers. I have real estate prices going back to 100 years. So I can tell the machine that for every year, for every month, these are the prices for houses. So it looks like supervised learning is what I'm doing. Now, what am I trying to target? Am I trying to target a continuous variable or a categorical variable? This might sound like I just spoke French, but all it means is, am I trying to predict a number, a continuous number, as in like the price tomorrow will be $300.25, or am I trying to predict if it's going to be expensive or cheap, right? Categories, right? You can't have unlimited categories, right? Like if you were to think that $348 is a category, then $349 is a category too, and $350 is a category. That's too many categories. But if you go, you know what, anything above $100 is expensive, anything under $100 is cheap, then suddenly I'm doing categorical training, right? And so now that I know that I actually want to predict how expensive the house would be in terms of price or dollar value, then I'm going to do regression. At this point, 80% of my problem is solved, right? Now I know that I'm doing regression training, right? And I have my data set. And so what I need to do is I need to go into the library that I'm using, and I'll talk about the library in a second. But I'm going to go into the library I'm using, go into basically the documentation where it talks about regression, and I'm going to choose something. So I'm going to just go to a library that I recommend everyone use. Do not use TensorFlow. I think a lot of people have been turned off. TensorFlow is a fantastic library, but I think a lot of people have been turned off by machine learning because they install TensorFlow, they go through all this stuff, and they're like, well, what the hell was the point of that, right? I set up some tensors, but like, what am I actually doing? So don't use TensorFlow, right? Use something called scikit-learn. So let's go to scikit-learn, right? And I go to scikit-learn, and now I'm here, and I will go to getting started. Oops, I will actually go back. I will look at the scikit-learn homepage. They actually changed it. So now, looking at this chart, I know that I want to do regression, correct? So I go to scikit-learn, which is a library that I'm using in Python. Unfortunately, I recommend everyone learning Python. I know it's always tough learning a new language, but I say learn Python because everyone knows. All these libraries are in Python, so I strongly recommend you learn Python. So I go to scikit-learn, and I click regression, and now there's tons of different regression libraries, right? And so now I can literally go through each one and go, does this really fit my use case, right? Typically, I always recommend just check out logistic regression, right? And it has a bunch of math on here. This is not what we're looking for. So let's actually go to the API, right? And then let's look at linear model. There we go, right? This is what we're looking for. So here's all my linear regression models. I can click logistic regression, and see sample code, how it works, and what I should do is copy and paste this code into my code base and see what happens, right? I fill out the parameters and I let it run. And so this is what I do. Now I promise that, there's not a lot of code in this, and there isn't. This is for people who are comfortable with coding, but there's so many tools that exist that you don't even have to code. And I actually have 9 minutes, so I'm gonna speed this up. So here's the tools that you need. So if you go to AutoML on Google, right, on Google Cloud, Google Cloud AutoML is a tool that lets you upload stuff. I'm not going to go through the example because I totally didn't realize I'm almost out of time. AutoML on Google lets you upload your data, and it will automatically run these algorithms for you, right? All you need to tell it to do is which variable are you trying to predict. So for example, right here in this example, I upload a data set and I go, okay, here's all my columns. So this is a Google Sheets that I uploaded, right? So your business can send you a Google Sheets and say, Faisal, can you predict what our sales are going to be next month, right? And here's all the sales, including how many users were on our website and all that stuff for the past 10 years. What is it going to be next month? You take all that, you format it into a Google spreadsheet, you upload it to AutoML, and you say, please predict deposits or sales next month, right? And then I hit train model. That's it, right? I didn't have to know about the algorithm that's driving it. I just need to know the concepts, right? So I knew that this is a regression model. So I need to tell AutoML, this is going to be a regression algorithm. Please train my data and get me a model, right? And then you get an API that you can actually tell anyone to use. So AutoML, fantastic. If you want to try Python and scikit-learn and stuff, I recommend, if you're getting started, don't download it on your computer. What you should do is just use Google Colab, which is basically collab.research.google.com. It is a way to run and train your models not on your computer, but in a Jupyter notebook on the cloud, right? And this will make your life very easy. You won't get stuck 2 days just trying to configure Python and get stuck on it and different versions of Python. You can just use Google Colab. Now, if for data sets, a lot of people go, well, how am I going to get these data sets, right? I want to learn, but I don't know what to do. Go to Kaggle, right? Kaggle is the best place to get data sets. For example, I went to Kaggle and I found this data set called Heart Disease UCI, right? I hit download, and now within a minute, I have all the data sets for a heart disease. Let me actually show you here, right? And so this person's age is 63, female, whatever, all cholesterol levels, all that stuff. Kaggle's made all this stuff open source. I can take this data, put it into AutoML, put it into scikit-learn, and I can start learning machine learning very easily. Lastly, before my time runs out, I recommend everyone buy this book, Machine Learning with Scikit and TensorFlow. Unfortunately, I did not write it. This is purely me saying this is a great book if you want to learn machine learning in a very pragmatic way. This book will not bog you down with the math and the theory. It will, the theory is there. It won't bog you down with like the math and equations. It will explain to you the theory. It will give you a complete intuitive understanding of machine learning, so that your only task after understanding this is using the right libraries, right? Using scikit-learn. Once you understand scikit-learn and you understand that, what, I now need to use TensorFlow or PyTorch because that's what my problem requires, you will be able to use it. It's almost like learning React or Vue.js or AngularJS, right? Once you understand how Redux works or the two-way data binding works, At that point, it's just a matter of looking at the API docs and filling in the blanks, right? Because you got to intuitive understand it. So that's what I recommend everyone do. And what I recommend is email me or send me a tweet if you are getting started. I kind of rush it at the end because I have another talk in 5 minutes. But if you want to learn more, if you want to see more examples, or just ask me questions about how to get started in machine learning, just send me an email or send me a tweet. I'll point you to the right resources. One thing I want to say is machine learning is not just for PhDs. It's not just for people who are good with math. It's like, when we were growing up, or at least I was growing up, I'm 30 now. So, when I was like 16, it was like, well, you have to be extremely good at math to be good at programming. Yeah, that probably was the case in the 60s, right? When you were doing like punch card programming. It's not the case in 2020. And so it's the same with machine learning, right? You don't need to be a PhD to understand machine learning. You just need to understand the intuitive concepts, build a good intuition, and then find the right libraries for it. So with that, thank you so much. If you have any questions, please send them to me. Yeah, no questions. And what I do recommend is fill out the feedback and quiz form. I think that will be very useful, and you will win a prize. I don't know if you know what the prize is, so I just won't tell you. But yeah, thank you so much. Awesome. And there's no questions. So, and if you're interested in Flutter, join me in my next talk where I talk about how to port your Android and iOS app to Flutter. Awesome. Thanks, everyone.